So I'm Jeffrey Jacobson. This is Mazen, Sonali, Suleiman, Jason, Manali, Alicia, Steve, and Dave. And our intention was to use a combination of VR and AR to achieve extreme precision in design coordination and collaboration between the home office and the field. So to start with, we're putting this complex, geometrically complex model in VR because it has a lot of complicated shapes coming together which are difficult to visualize from two-dimensional projections. And perhaps all of you are clients, stakeholders, members of the public. You're not architects. You're not going to visualize the same way from just from drawings. So here we can all see the same design. Now we're setting up our remote link to Gus, who's out in the field. He's going to show us an AR application, and he's going to position a virtual object into place where he wants it to be. And the idea is that the object will be moved into position in our environment here. So we'll do that in just a moment, as soon as he gets it. Very good. Let's see.
Guys, we're so intrigued right now.
Yes, actually. This is mixed reality right now. You can actually judge a person's height. So here's Gus. Hello, Gus, can you hear me? All right. So how's it going, Gus?
You gotta open the doors when they're
Yeah, so I'm gonna go check and make sure he's really down there. This could be a great.
Gus? Hello? He's muted. His audio is muted. Okay. All right. Yes. So we were not able to integrate all of the parts of our project. So we're going to show you each piece. So we're going to show you two laptops that are connected. Three laptops that are connected. So you have objects that are moving in one environment and it's shown in the other environment. Here, our Skype guy. What happened? Can you get the Skype back? Oh. Well, the time is good. So the use case is that we want to be able to move an object in the field and have it move in the virtual model in a way that we're not calling out inches or measurements. You know, if he says over the phone, move this 3 inches, he has to estimate that. Then I have to hear it and estimate it again in my own imagination. So that's 2 levels of error right there. Or he can issue an RFI, which is on paper, and that's really slow. This way, if you move an object in the field, you see it reflected in the VR, he can move it to where he wants it to be. Then we can see if there are any clashes deeper in the design as a result of that move. So we can move the object in the VR, and it's reflected back there on the AR. That is, that's when we get all this working next week. Is the Skype up? Good, Skype working.
What's the
Good question.
underlying basis model?
This,
Software.
oh, the software, we're using Unity. in both cases. So I believe Sonali and Malali compiled a single Unity application that we're able to run in 2 places. So you start it up and you're going to run it in home office mode, or you're going to run it in augmented reality mode on the tablet.
Like a multiplayer game?
Yeah, it's exactly using the multiplayer code. Dave wrote some code that allows us to dynamically insert any object into the environment. So, and move it around. So you can use it for brainstorming. Let's say we want to make modifications to this building and can bring in different objects, different features, move them around. So you could use it in many stages of the design process.
So this latter potential project is basically in either the AR or the VR version, happening in the tablet or
But it would be a laptop, it would be the icon, it would be a phone, it would be any device. And all would be doing simultaneously.
Absolutely. And of course, if we can work with one person in the field, we can work with several. Right? And so in this way, the person in the field is integrated with the design team in the home office. Aha, here we go.
Yeah, just to clarify, this comes up.
Yes.
So the person in the field, this is the case where you're in the midst of construction, am I understanding that correctly? And
It could be.
there's a potential clash that wasn't detected earlier on, but by you moving it, it will potentially clash maybe again with something that's not yet in place.
So the person in the field encounters something that is not visible to us here at the home office.
Yeah.
He makes a suggestion, he moves the object. We may or may not see a clash that is not visible to him.
But it's not in place yet.
Or it's not, right, like there's mechanicals that are going to be in, in a certain location.
But earlier in the structural field process, and there's
Exactly,
HVAC coming right through there that you would see that you may not.
exactly.
Excellent.
So it's a, there we go. Can you show it on a second screen? Or,
We have 2 screens, so
oh, there's the other one.
it's still my screen. So what we really tried to do is, what our vision was, that the field guy or Gus is going to be moving, he's going to use his AR app and try to look at the light or whatever he wants to move, and move that, and simultaneously it's going to move in our virtual environment. And we almost got to that. So what we're trying to show you with this demo on the right is that I'm just sitting here with my laptop, and there's these 2 squares that are moving, but I'm not moving them. Both my hands are up here. It's not magic, but we're just connected. We're in a multiplayer game right now. And so the idea was that all of us, different stakeholders, the engineer, the guy on the field, the designers, you could be sitting in Seattle, you could be in a virtual environment, or you could be with your mobile app out in the field, can move things in the virtual model and see it all together. So say I move my light tray up, the guy in Seattle says, you can't do that. And the designer says, well, how about move it 2 feet or 3 feet? And so we all see together. We almost got the coding to get done, but because we were trying to do the AR, we were trying to move a lot of stuff, we tried to do the whole networking thing. Our vision was to even connect to the console, but because this is on Penn State hardwired network, we were having issues connecting to that. So we ran through a lot of issues, but the vision is to have this work as a multiplayer game and move different things. So these balls, so there's Alicia and there's Manali, they're moving these. One of them, so which one is which? Okay.
On the corner.
Oh, the sky was here? Okay, so we're going to switch back and forth, and I'm going to come back actually, or since it's already connected, you mind if, oh, we already got it. That's fine, that's fine. I'll come back and try to show what David tried to do also, which is, again, taking it to the next level of remote collaboration and trying to switch assets that we can move within a virtual model. So we made a lot of success with doing a lot of this piecemeal. everybody, so Suleiman downstairs was the AR expert. We were trying to get it working with the network. David did this whole new hack on switching different components that we could move. Unfortunately, we couldn't bring it all together to our vision, but I think we're really close. If we have till tomorrow, we'll get it done. If you're back to the call with the field guy.
Okay. Hey, can you hear us? Yep. Very good.
It sounds coming out of the laptop in case you can't hear it. It's quiet. Maybe hold the microphone to the laptop.
We get the microphone.
Okay.
I think he's working.
Well, all right, trust us. The AR app is working. It's on the tablet, he is able to move the object by simply pressing the button. You can drag it up, down, left, and right. That's what we were trying to show, but I Skype that from. Awesome. All right.
Awesome. Yeah, thank you guys. So, any other additional questions from the judges? We have some, some.
We have another component to show you if we have time.
You have, while the judges ask questions, to show that behind the person answering the question.
Oh, sorry.
Yeah, so questions.
What type of objects can you move or insert?
Sure.
Any dim object?
Yeah,
You have to pre-select
here,
it?
Dave answered. Yes, any object.
Okay.
So the way the dynamic objects work if they're loaded is that you can load any FBX file or any 3D model into Unity. You then export that as a special type called asset bundle. An asset bundle can contain any 3D model, can contain images, can contain anything really that Unity is able to import. It does take custom code to write the asset bundle. That was some custom code we wrote. You can then take that asset bundle, put it on, say, Google Drive or Dropbox or anywhere. Your other person, the other office would load that, and you can then dynamically load that from a certain location into Unity. So really, the possibilities are endless. As long as Unity is able to load it, you can load dynamically any kind of model, Revit, FBX, OBJ, anything like that.
Could you use this to keep as-built conditions up to date? So say a facility engineer notices that there's a pipe that is in a different location, and he updates it so that the as-built BIM is up to date?
So this does really have the capability for exporting like a saved condition, like you moved it, it's not to save that. And something like that would probably be better served by 3D scanning. That was something we considered maybe saving a location. This would be more for if you encounter an as-built condition after the fact that you weren't aware of, and suddenly have a clash because of that, because maybe you didn't do 3D scanning, and then you have to move things around. But then after moving them, and there's another clash, you can get people together to say, okay, the as-built condition wasn't correct, sorry, let's try and figure this thing out together.
Okay, so going with what he's saying, what we had envisioned was, if you're the field guy, you would click on this, and we tried to do some of the networking thing, but that didn't kind of work. But you can pick any model and move it. And now what David will help show is how he can switch whatever you see as a house to another component.
Yeah, so what you're seeing there is a temporary placeholder model. You can see you could click it, it would highlight, and then you can move around with the arrows. You could also theoretically click on other models, but we don't have those loaded in the scene. So right now, we are on Dropbox, and saved in the transfer folder is an item there called Fungus object. So we are going to download an object from Dropbox. It is going to be a different object. And we're going to save it to a given location. To the best of my knowledge, asset bundles require either a relative path, which we can't do because the program is compiled, or a hardcode path. Our hardcode path is in the C drive. So it's downloaded. We have a folder called C Fungus loaded. And so we're going to save over Fungus object. And what should happen is that when we start the application again, the object's going to change. So it's dynamically loading from the C drive, whatever object is there. So that sort of answers the question of how would you know which object is the problem? Well, you wouldn't at first, but then you would send this model out to everyone, and then they could solve it together that way. So we're just going to need to find the object to save over.
So while you guys do that, any question from our online judge?
Yeah.
So, I think the context of the purpose of this one is very clear. I think very important one is information on the printing part of this, and I think very much. And there are the tools like total station, this you can picture distance, measuring tools like total station using field, and you can make this one with this subject reality, not just letting a field engineer looking for myself, but actually this person. That would be an interesting future question.
Well, since we're moving the object a discrete distance using controls, that can be recorded to display on the screen. So if he touches the button 3, 4, 5, 12 times so it looks right, the application can tell us what that distance was. That would be a way to implement that. We could also use virtual measuring tools in the VR. A lot of
It may have been hard to see, but at the bottom there was an indicator that maybe it wasn't there. It may be hard to see, but in the executable, there's an indicator at the bottom that actually told you how far it moved in each direction. In particular, this resolution and brightness. So for
My question more about the real mechanics about this virtual environment.
You mean measurements in the virtual environment?
Measurement is real artificial environment versus design environment.
Sure.
Although you are counting on the function, right?
Yeah.
But the engineering is the business. So I
Well, since it's an AR, you could put the measuring tool in the physical space near the virtual object. So when you move the object, you can see how far you moved it as a check on the scaling of the augmented environment. So that, if I thought I moved it a foot in AR, I can see with a ruler, did I really move it a foot? Theoretically. But we're in vaporware land at this point.
Well, nice work. Any other questions from the judges? No? Okay, thanks, Team Fungus.